Today, today I want to go through the Polya's four-step problem-solving process with this problem here. So if a wheel has 8 spokes, how many spaces are there between the spokes? So in step 1, understanding the problem, I think it's important to know that we're looking at a wheel here, but then spokes is really the thing we need to make sure we understand. So we could do that by looking it up, we could do that by talking to other people. If we know what a spoke is, we may want to verify that. And then what other things do we know? Well, we know we're talking about 8 spokes. We know we're looking for the spaces between the spokes. And maybe understanding this is key to understanding the problem as well. So what we're looking for, how many spaces are there? What we know, we've got a wheel, it has 8 spokes, and then we can kind of go from there. As for a heuristic, I think a lot of people are going to use resources outside of themselves to maybe find a picture of a wheel that has 8 spokes. I was able to do so online pretty easily. But if you're not going to do that, and since I remember what a spoke is, I would probably choose to make a sketch. Okay, try to draw a sketch to represent the problem. So I'm going to do that here. So I need a wheel. Notice this is a sketch and not a perfect to scale drawing. Okay, here's my outside rim of my wheel. Here's the inside center of my wheel. And here's 1 spoke, 2, 3, 4. Notice that as I'm drawing these, I can actually count the spaces between them. And by the time I've drawn 4, I should be in a good place to use inductive reasoning to guess the answer. But I'm going to keep going. So here's 5. Here's 6. Here's 7. And here's 8. And it really bothers me that this is not somehow 3-dimensional. I don't know if that really did it, but okay. I've got my wheel, I've got my 8 spokes, so now I just need to count. I suppose first I should double check. 1, 2, 3, 4, 5, 6, 7, 8 spokes. And then I've got 1, 2, 3, 4, 5, 6, 7, 8 spaces in between them. So we did step 3, we carried out our plan, we solved the problem, and we got 8. Now we want to reflect a little bit. Are we sure we're right? Well, these things are spokes. These are the spaces between them. I feel pretty good about that. Can we check our method? Yeah, we could go online, like I said, and search out a picture of this to see if it matches ours. That would be another way we could solve this. We could check with someone else who solved this problem or someone who's never solved this problem and ask them to walk through what they would do. As a note, if you're going to outside resources for help, especially another person, don't start with what you did. Start with what the question is. Because if they read this question and they get a different answer, you want to see how they got that different answer and what their thinking was. If you ask them this question, you're like, I got 8, they'd probably say, yeah, that sounds right. Okay, so you want to make sure you're not giving them predisposition to just agree with you by telling them what you think. Okay, other things in looking back. Are there other things we can apply this to? One of the things I thought of was a pizza, right? If you've got a pizza and you're making cuts in it and they're all through the same point, how many pieces result from each cut? Right, so here I have 3 cuts using my pizza cutter. I don't know what that's supposed to be, but right, 3 cuts results in 1, 2, 3, 4, 5, 6 pieces. Will I always get double the number of pieces when I cut? That's something I could think about. That's a related problem to this one. You can start to get farther afield. What if these don't all go through the same spot? What happens to your cuts? There's a problem about a bar of chocolate. Right, so if you've got a bar of Hershey's chocolate, how many times do you have to break this to get all 12 pieces? And if I break it, once here, and then like break that piece here, and I've got 2 breaks, and I've got this piece separate, a group of 3 and a group of 8. Like, how many breaks do you need to break all those pieces apart? A related problem. That one's much harder than this one, I think. But those are the kinds of things we want to think about after we're done solving a problem. It's just, what else could I do? What did I learn here? How does this apply? What if it had 9 spokes? What if it had 100 spokes? Like, did those things still match up? So just thinking about that a little bit, looking at our pictures or our internet resources or however we solve this problem to help cement it in our head.